Hello everyone, welcome back to our course. This chapter is mainly about Kafka, which is a distributed publish-subscribe messaging system in Big Data platform. Firstly, we can have a look at the introduction of Kafka. Just as shown in the slide, Kafka is a distributed, partitioned, replicated, and zookeeper-based messaging system. This definition shows several features of Kafka. Again, Kafka is distributed, which means that it has a good performance and scalability as well. And it uses partitions to improve the throughput, while uses replicas to improve the availability. Besides, the key point is that Kafka is highly dependent on Zookeeper. And perhaps you are wondering, what is a messaging system? Simply speaking, a messaging system consists of one or multiple queues for message delivery, and each message queue provides an asynchronous communication protocol, which means that the sender and the receiver of a message do not need to keep in touch with the message at the same time. The message sent by the sender is stored in the queue until the receiver gets it. And you can just consider Kafka as the postman or the newspaper boy who serves as the intermediary between the customer and a producer. By the way, currently there are many message queues in production like Pulsar, ActiveMQ, RabbitMQ, and Kafka, among which Kafka is the most suitable one used in Hadoop ecosystem. What's more, we mentioned that Kafka is a publish-subscribe messaging system. But there is also another type which is called point-to-point. So what's the difference? Actually, it is really easy to understand the point-to-point messaging system. Just as shown here, the key point for this type is that a message in the queue can only be consumed by at most one consumer. And once consumed, the message would be deleted or moved out from that queue. That is why we call it point-to-point. But as for publish-subscribe messaging systems, things are totally different. In this case, a system could have multiple queues, and now the consumption unit is called a topic. To receive messages from the system, consumers need to subscribe to one or multiple topics, and each message in the topic can be consumed by more than just one consumer. To make an analogy, you can consider using this type of messaging system like using YouTube. Suppose that you want to learn big data from YouTube, you need to subscribe to a topic called big data, or maybe subscribe to a YouTuber who teaches big data very well, right? Then, after subscription, you will be notified every time the video is updated. And meanwhile, others could share the same video with you even after you finishing watching all of them, right? So this is just an easy way to understand the concept of publish-subscribe messaging system. And again, Kafka is just a typical publish-subscribe messaging system in production. And here we list several features of Kafka. Firstly, the time complexity of Kafka is in order 1, which means that the reading and the writing efficiency is independent of the data size, so it is very suitable to process massive data in terabyte or even petabyte level. On top of that, the throughput of Kafka is also awesome. Here, we mentioned that a single node system can transmit 100,000 messages per second. This is really a large number of data. Moreover, in Kafka, the messages can be partitioned and distributed, which consequently improves the concurrency and access efficiency. And meanwhile, the order of messages is remained perfectly by Kafka as well. Therefore, Kafka can be applied in both offline and real-time data processing in production. And that is the reason why more and more people prefer to use Kafka in Hadoop platforms to assist big data analysis. And if the performance of Kafka is not good enough, we can use the scale-out strategy to reach a linear scalability easily. Next, let's have a look at the Kafka topology. As we can see from the figure, there are three rows in this topology: producer, Kafka, and consumer. So quite literally, producers are the guys who produce all the messages, like the front-end web pages or some log services, etc. And consumers are those who require messages for further analysis or data persistence, like HDFS, MapReduce, Flink, Hive, etc. And in the middle, we have Kafka, which asynchronously transmits messages from producers to consumers. But here, please note a flow in several properties. Firstly, Kafka servers has a particular name called broker. Namely, each broker is a working instance of Kafka. And in the Kafka cluster, there might be more than just one broker. Secondly, the figure tells us that it is producer who pushes data into broker, while it is consumer who pulls data from broker. This means that broker is always passive, because Kafka doesn't know when the data will be produced, as well as when the data is needed. Thirdly, all the processes and all the components are monitored and controlled by Zookeeper, which is exactly the reason why we say Kafka is Zookeeper-based. If there is only one thing Kafka can't live without, it's Zookeeper. Okay, and this page just shows the basic concepts and their description. Some concepts like broker, producer, and consumer are already introduced before, and next we are going to introduce topic, partition, and consumer group in detail. Alright, so let's take a look at a concept called topic at first. Topic could be considered as a combination of one or multiple message queues, and the consumer needs to subscribe to some particular topics for data. On top of that, in each queue, there may be massive messages, and all the messages are ordered perfectly based on their generating time. Here, we can see a figure showing this. In this figure, we can see a topic with only one queue, and in this queue, each blue box corresponds to one message. Producers here only append messages to the end of a queue, which is on the right hand side of the queue. And the consumer reads data from the oldest to the newest. That is from left to right. and the position of each message is recorded by the offset, which can be regarded as the index. Just now, we have shown a topic in Kafka with only one queue, but in most cases, there are many queues in each topic. By doing so, multiple clients can concurrently access different nodes to read and write messages of a topic, and therefore we can improve the throughput and concurrency of Kafka. Now, we give each queue a name called partition. Here, we emphasize that each partition physically corresponds to a directory for storage, so they can be read simultaneously. And in each partition, the messages are perfectly ordered and immutable, and this order is also recorded by the offset. So, what is an offset? Simply speaking, the position information of each message is called offset. And please note that an offset is a long integer. This is not a string or a float number, but a long integer. Besides, it works like a bookmark when consumer is consuming data. When we are reading a heavy book, which has thousands of pages, it is impossible to finish it consecutively. Therefore, we tend to insert a bookmark to record the latest page we have finished. And this is just the same case as using offset. The offset is like the page number, and each partition has its own independent offsets. Every time a consumer is consuming messages from a partition, it will record the offset. And next time, it will start from the latest one in case of duplicated consumption. And also, this offset mechanism guarantees the perfect order of messages according to their generating time as well. Apart from all the basic concepts we introduced before, there are also some other important ones like replica, leader and follower, and the controller. All of these concepts are relevant to the replication mechanism, which is set up to improve the data reliability and cluster availability of Kafka. As indicated by its name, a replica is a copy of the partition to ensure high availability of the partition. And the first replica, or namely the primary replica, which is written by the producer directly, is called a leader. Both consumer and producer only interact with the leader. Meanwhile, all the rest replicas which are copied from the leader are called followers. The followers just keep copying data from leaders, and they stand by in case there was something wrong with the leader. And the guy who monitors and elects leader is called a controller. Alright, that's all for Kafka. In this chapter, we mainly introduced the basic definition of Kafka, the key features of it, the topology, and some important concepts of it, which is the key point in this chapter. Hope that you are enjoying all the contents in this chapter, and see you in the next chapter.